I'm Clint Checketts. I work for a company called Domo out of Utah. And yeah. This presentation, over the last several months, we implemented CloudFoundry. Sorry, not CloudFoundry, config server. Thinking about something else right now. And so I want to talk about kind of the thoughts that we had and some of the things that we added to config server. Goodness. To config server to make this happen. So let's get right to it. Before I start off, I got to thank my team just to keep the narrative brief and just to keep it flowing pretty well. I want to say I did all these things, but really it was my team, especially a friend of mine, Steve West. So this all started when we were given the request, hey, we need to get all of our configuration under source control. And that was the business requirement. When you start a project, just like you have to have a reason for doing it. It's nice to do little proof of concepts and things, but the request of get our configuration in source control was kind of our rallying cry when we said this is our chance to try config server and to really push it and get the benefits from it. But the thing I want to acknowledge is use config server and get your configuration in source control are two completely different things. I can figure out a way to make them tie together. I could just go to all of my servers and all of our databases and everywhere and dump all that configuration into source control, and we get the same benefit, right? Where we could see, what had changed over time, that history, but you wouldn't get the full benefit. And so that's it's the difference between dumping it or driving your configuration from source control, and that's where config server comes in and really helps us out, because once it's driven, once that's the source of truth, you can get a lot of benefit from there. You can use it as your normal workflow does, right? Pull requests, history, see who's committing stuff, commit messages, things like that. In fact, as we started this, I had to run a script, and that script would go and scrape all of our configuration and put it in this source control. And we were just trying to get the initial values. And the first thing that happened, I came into work one day, and there was an angry email saying, Clint, why did you change this? And I was kind of confused. I didn't change anything. And what had happened was there was an issue, and someone had tried to figure out, oh, here's the property. Who set this property? They couldn't see. Oh, let's go search through the source control. And they found our repo for our proof of concept, and they found that it was me and that I'd made that change on this date at this time. And so there was certain, that was the root cause. Obviously, it wasn't me because it was just our script. But what it really was great about that was it showed that there was a need for this, and that even without us teaching people how to use it, they already inherently knew how to use their source control. Before I go any further, I want to kind of cover what config server does, just to kind of level set for anyone that's new to it. The most fundamental part is it's going to store configuration, right? Keys and values. Very, very, very sensible. Not very complex in that, but how it does it is where the power comes in. If I'm going to store stuff in there, I'm very likely going to be storing secret stuff in there, and so that's why we need to be able to encrypt it and decrypt it, so config server supports that. It also has something called refresh scope. In fact, this was the gateway tool that got me into config server. In fact, the week that it was released, I went and grabbed the refresh scope aspects just because I wanted to be able to refresh the beans that would change properties and things like that. And so I'll dig into refresh scope some more later. But that's something else that Spring Cloud Config brings in. Also, just like any Spring tool, it's backed by many options. So the default one is using Git to store the config, but there's other ones out there, console, database, etc. I won't be looking at any of those. I'll just be talking about the Git aspect. And frankly, the Git ones worked very well for us. And last of all, it's extensible, and so there are specific use cases that we ran into and needed to add stuff onto config server, and so I'll be touching on some of those things. And in talking with some of the Spring Cloud guys, maybe these are things that could get pulled back into the main project, but if not, the demo and all that code's on GitHub, so you'll just be able to pull it in and use it if you need it as well. So, and if it's not, then open an issue on that ticket and say, hey, Clint, you talked about this and you didn't put it in the repo, make sure you get it in there. So let me know if that happens. So that's config server. When using Git as your backend for config server, it really lets you push those properties out. But when we rolled out config server, we had a legacy system, a system that the way it worked is it happened to be in charge of all the deploys of all of our services. And so it knew about all of our services. And because it knew about all the services, it just happened, it's kind of one of those scope creep kind of things. It says, oh, I know about all the services. I'll also push all the config out to all those services. And so that meant that it would deploy a service, give it some config, and then whenever config changed in our system, it would go and actually hit an endpoint and say, hey, here's your new config. And so that's a push model. Config server, though, uses a pull model. And so I just want to kind of note the differences. For that push model to work, the system has to know about all your servers, right? If you tried deploying using some new mechanism or a different thing, moving things out via Docker or CloudFoundry, or if something else is deploying that isn't that system, then you're stuck, right? The other thing is pushing. The server has to be up before you can push, but it needs config before it can be up for you to push to it. And so really we ended up pushing in two different ways. We'd have to write it to a file system on deploy, let the server come up, and then push it again to an endpoint, right? And so kind of the shortcomings of that push model, and config server uses pull model. And so in that case, it still needs something. It still needs to know where the config server is, right? So it can go and pull down its stuff, but really that's all there is to it. And when it starts up, it can pull it down. Whenever it's notified there's something new, it can pull down the updates. And so that pull model, Spring Cloud and a lot of the Netflix OSS stuff really shows how this, having the deploy system know about everything really isn't the most powerful. It's better for the servers to come up and register themselves or come up and pull in their own config. To really understand the power of config server, you're going to see, I'm going to actually cover a lot of maybe fundamental Spring concepts just because the way Spring Cloud leverages them shows how powerful they are. So there's the Spring environment, and I'm not talking about the Spring ecosystem of libraries, but there's an actual class called environment, and there's subclasses, composite and configurable and so on. And the Spring environment is, frankly, it's one of my favorite things about Spring. Spring Boot really made it powerful with the relax property resolver and stuff like that, but what the environment is it's made up of many property sources. And so a property source is a source of properties. It can be the environment, it can be the command line, it's your application properties file, your YAML file, and so on and so forth. And it's extensible, so I can add on other property sources to it. And so when you think of the environment, think of these property sources. And it's something that you can just go and add in another property source to it, and so it's got a precedence. So I'll explain that in the next slide a bit. The other things the environment brings is profiles. So this is nothing new about Spring profiles. You can treat those like environments. I'm running locally or in dev or prod. And when you want to get values out of the environment, you could programmatically call it, but the annotation support's fantastic. You just do an at value and you pull it out, or you use configuration properties. So just a little review there. So to talk about property sources, we've got that precedence. So here's an example of a couple keys. We've got key 1, key 2, key 3, just to be simple. Bootstrap YAML might be a little new to folks that aren't familiar with Spring Cloud. Once you start using Spring Cloud config, it goes and starts looking for this Bootstrap YAML. And it's, like the name says, it's when it's trying to bootstrap, it's trying to start up. So it's the very basic stuff that belongs in that YAML file. And you want to keep it minimal. And so that's your lowest precedence. And then on top, it's going to look in your class path for anything you got checked in an application YAML file or a properties file. Then it'll look in the environment, and so on and so forth. And so by there being that order, that precedence, then the first time it finds it in that precedence wins. So in this case, key 1 is Apple. Key 2, even though it's declared in the application YAML, it's overridden, it's dragon, and then shark, right? So that precedence is super powerful because then config server can go and it can inject itself as a very early one. Meaning, okay, I've started up my system, but config server can kind of override it. So it's in a place where it can override anything. That being said, it makes a lot of sense to keep your properties as close to your application as possible. So check in as many as you can, and config server is really there primarily for your secrets or for things you need to override, right? So in this case, you can see that now key 1, key 2, key 3 all have new values. Config server is nice in that it exposes all this via REST endpoints. We all understand that this is a very systems can just call the REST endpoints and get the values. And so we're going to look at 4 endpoints that it offers. One is the config endpoint, and it's got a name, profile, and a label. So to kind of break those down, the name is the application, what it calls itself. The profile is the Spring profile. So in config server, you might think of it as the environment or however you want it to identify. Maybe get different properties when it's called, running in the cloud, something like that. And label is, in thinking about Git, is your repository tag. Depending on the different backends, it can mean different things. Like it could mean a subfolder in another implementation. But with Git, with the Git backend, it means the label in your repository, whether it's a tag or a branch. To encrypt and decrypt, they're just an encrypt-decrypt endpoints. You just can post and get against those and get those values back. Or sorry, no, I guess those are post in both those cases. And then to do a refresh, because if a property's changed, you need to kind of ping it to say, hey, something's changed. Maybe you should go and pull down your new config. So that's what those endpoints are. 2 other points. So here's a controller. And notice it's annotated on line 10 with a refresh scope. And what refresh scope is, it tells the bean that's going to behave a different way. Under the covers, really, it's just saying I'm going to wrap this in a proxy, and whenever the scope's refreshed, I'm just going to throw away my internal one. And so whenever you refresh the scope, it's going to call the constructor again. So obviously, you don't want to do work in your constructor, but that's kind of the offset. Once you put refresh scope on it, it'll get refreshed. And since that refresh can happen late, you could kind of think of it as a lazy initialized bean even, right? So that could surprise you. But that's how you would get a value. So in this case, we've got the @value annotated greeter.name, and then there's the endpoint where if you hit / you get hello, name, world, Clint, whatever. So here's an example controller. We're going to look at that in the demo some more. One thing I want to point out, though, and kind of I might be beating this a little too much, is once you put refresh scope on your bean, then that constructor could potentially get called multiple times. And so the solution, well, that's pretty harmless if you've written your code with that expectation. But configuration properties is the alternative, where these are beans that just hold configuration. And so you'll notice that this is not annotated with refresh scope. That's because it's automatic. Spring knows, hey, if this is a bean that only has configuration in it, it's going to be OK for me to re-init it all the time. Not a big deal. And so configuration properties are great. They also offer type safety, auto-completion in your YAML files. There's other reasons why you'd want to use the configuration properties classes, so they're very useful. Okay, so let's look at a demo of using those. So this is online. You can get it under Checketts config server example. I'll put the URL on the last slide as well, so you won't have to pull it up. I want to show you some other cool things. This is kind of a fun thing. When you check it out, if you run Gradle W idea, it actually is going to, let's see, actually have it go and generate your run config. So you'll just be able to go and pull down the run config. It's auto-generated for you. It'll just work. So that's kind of something we've really liked doing. Okay, so I have just started the server, and it appears that I had started the client beforehand. One thing to note is when it starts up, if the client can't reach the config server it's configured to talk to, you'll see this warning. It'll say, could not locate property source, yada, yada, yada. So you can see it was trying to go and find the local profile against that URL. So there's a property where you can turn it on to tell it to fail fast. So if it hits that point and says, oh, I can't get my source, then just blow up and fail immediately. So that's something you can use. So in fact, let's restart this one so it's actually got its source now that the config server's up. This repo, when you check it out, I'm assuming you'll check this out, right? There's an app in there and a server. So the server is the config server. The app is the client. We'll look at how that works out. And there's also this folder called sample config repo. So let's look at that. Before we go there, under the server, in its resources directory, there's a bootstrap YAML file. So can you guys see that? You want me to zoom in? Okay. So config server can be a client of config server. So that's fantastic because when your config server starts up, it knows, oh, I can look in the same repo that all the other services are looking. And so if there's anything configurable about your config server, you can put it in the same repo. So you just enable that bootstrap true in the server itself. You wouldn't typically, oh, time to go home. You wouldn't typically do this in your clients, but in your server, it's very handy because you don't have to think about, oh, that one's special. We have to do a redeploy when we change stuff. It just behaves the same as the rest. Okay. The commented part was a get equivalent. The other part is the application name. So all of your applications that are going to be clients would declare their name, so they know when they call config server, they say, hey, I want the configuration for myself. And there's a hierarchy where they'll get their config. They'll get the config for their profiles and their config, as well as a base application .yaml file or properties file. So there's kind of a nice hierarchy where if you got shared stuff that all the applications in the same profile or environment would use, then they can kind of share that. So that's kind of handy. We've got an encryption key. I'll demonstrate that with the encrypt endpoint. Typically, this would be a much longer randomly generated key, but just giving you an example of a symmetric key. The other parts, these last two parts, are specific to this demo, but they're very powerful. When you enable the native profile in your config server, then it tells it, go and use the native repository. And native repository just means a file system. And so here, this other one is just telling it where to look for that. And so now back to this sample config repo. What that means is I can start up my config server, and I've got the repo in a folder next to it. So it makes it very easy for your tests to be able to validate that the values it's pulling through work exactly. Or if you're iterating or demoing, then it's very handy. So that's why I wanted to point that out and what that's doing. Other than that, there's not really anything else going in the Bootstrap YAML file. It just starts up and it's able to serve stuff. So I'd showed you that sample controller. Let's show you that in the code as well. So here we've got our sample application. It's a Spring Boot application. We've enabled config server. This is the demos you've seen in the keynotes before. And then we just go and start it up. We also declare the home directory so that our native repo can leverage that as a property. But other than that, that's not anything special. OK, so here's our controller. And it just, on startup, it injects in one of those configuration properties, pulls it out, and you can serve it. So let's have a look at that endpoint. So hello, Carl. And it says from first, second, third. So these are two different properties it's pulling in. If we go back and look at here, we see that hello, and it goes and gets a name. And then it goes and lists out 3 different values. So if we had the question, where did this come from? Where is this property coming from? There's actuator endpoints. And so again, this isn't anything Spring Cloud specific. This has been in Spring Boot for a long time. But if you use the env endpoint, you can get a lot of insight. The env endpoint goes and it lists the profiles, but then after that, it goes and lists all the property sources. Remember how I was praising the Spring environment, how it has these property sources. So here I can see what all those property sources are without even having to debug anything. It's exposed at the env level. So in this case, I wanted to see where the greeter name came from, Carl, and I can see the source. It came from the config server, and it's in the config server example YAML. So if we go and hop back over to our repo, we can see it's in the config server example, and there, sure enough, is Carl, right? So it makes it very easy for you to look at a service, see what are the properties it's got set, and then where is it coming from, so you can trace it back all the way back to the repo if you need to change it, or annotate it to find out who changed it. Yes? So the question was, is there a way to see which repository is it chosen from? Not quite. There's what you can do is the env endpoint lets you look up an individual property. So in that case, you can say greeter.name, and it's showing that the value, like let's say you looked through there and you saw there were multiple greeter.names, and yeah, you could have traced it out, or you're like, look, I just want to know what the value is. You could put it in there, and then you could go back to the previous view to see, okay, which one has that value? That's probably it. But then also the order on the screen is the order of the precedence. So you can trust it that way. So that's exactly how that works. So let's go and change that, because this is a repository. So we want it to greet me rather than, who's Carl? Is anyone named Carl here? Okay, it's not him, it's me. Okay, so, oops, didn't have my, all right, let's make this bigger. So if we go and curl localhost, see, was that was our server, right? So we'll just go and hit the, you know what, I had an autocomplete, why didn't I just use that? Okay, so we're just going to go and hit the refresh endpoint for our server. And what that's going to do, really all it's doing is it goes to anything that's annotated with refresh scope, and it really just blows away the internal proxy. That's all it does. There's no other work going on. And so then the next time something goes to call it, it'll go and reinitialize it. So that's that lazy init. Notice that the endpoint returned greeter.name. Essentially, it noted what has changed in the repository since it had last refreshed, and it's returning that. So you could do something off that if you wanted to. So if we go back to our browser, oops, you can see that Clint has changed it there. And if we go to the root page, it'll have changed the other one as well. So there you have that. This first, second, third is kind of interesting because it shows how the properties were flattened out. Because really, even though you're using YAML, this is a common Spring Boot thing. If you're using YAML, you're not really using YAML. Spring goes and flattens it out into properties, key value pairs. So in this case, you can see how it flattened the YAML array into just a bunch of properties with some useful numberings. OK, so that's the environment. Let's see. Is there anything else that we would like to look at? Any other questions about these kind of demo stuff? One other thing I'll show, this is an extension, kind of a bonus feature, is if I were to encrypt something, actually, yeah, let's show the encrypt endpoint. So the question is, when the refresh scope happens, can I observe it? And yes, by default, it actually publishes a refresh scope changed event or something like that. It's very much a refresh scope happened event. So you could either inject in that scope and fire the refresh yourself if you want to do. I did that programmatically when I was first leveraging it. You don't need to in this case because the endpoint already exposes that. But then also you can watch for that refresh if there's other work you want to do when that refresh happens. So here's an example of encrypting something, and the payload is just my secret. And so in this case, the response is now that it's an encrypted value. And notice how every time I encrypt, it's different. That's because the initialization vector is rotating, so you're going to get more uniqueness. So it's not something else you could just guess. It's not repeatable. So once something's encrypted, so let's say we took that value, and in our repository, we go and put it in. So here, let's say I went and gave it a key, call it oops, and I'll explain why, and I go and put in an encrypted value. So let's go look at actually before I go there, you may have noticed that there are some secrets that you really don't want them leaking out. If someone has just hit the env endpoint of my service, they're going to see all of my properties, right? Well, there's a property where you can go and filter them out and say, oh, these are secrets. Make sure you mask them when the env endpoint and other things like that are hit. So in this case, key. I think secret, key, and password are the default ones, and you can extend those. So what if I were to encrypt something, but not have a key that was a secret, right? What's going to happen? So we'll go and hit our client on 8081 and hit its env. Oh, I added it in, so we need to refresh it. We'll just be lazy and we'll just restart it for now, because it restarts pretty quick. So obviously, if I'm not using a key that I told to mask, it's not going to mask it, right? This is the first of one of the extensions that we added in when we were using it. We said, hey, if someone encrypts something, they probably meant to keep it secret. And so let's catch it if we notice that it doesn't have a key that's going to be masked and replace it. In this case, decrypted value withheld, blah, blah, blah. It sounds like being overly cautious, but already in 3 cases, we caught this in lower lanes in dev when someone said, hey, this isn't working. Why isn't this working? I'm getting this weird garbage value. And we said, oh, well, change your key to something that has key on the end or secret or something. And then they realized, oh, yeah, I'll do that, and easily resolved before it got into prod and started leaking things out. So that was one extension to that we added. Yeah, so that's that. Let's get back to the slides. OK, what format is this? Easy quiz. No. Hold on here. I'll give you a hint. It looks like JSON. So YAML is a superset of JSON. Meaning, when I first read that, I was like, whatever, that's a typo. I'll just get on and do my YAML thing. By YAML being a superset of JSON means that it can do everything JSON can plus more, right? So you've seen the normal white space indented file shape of a YAML file. But it's very powerful to know that you can do JSON-like stuff. First of all, if you have people that really hate YAML and they want to put everything in JSON, fine, let them do their thing. And by the way, this supports comments, so they get that at least with some benefit. But you're probably more familiar with this kind of format of YAML, where you've got your keys, values, indentations for the hierarchy, things like that. There's a lot of benefits to this, namely because it removes a lot of the noise, but then also it makes it very, you have lists now that you can just put in there. You'll notice that the cipher text, I had to put single quotes around. So that's one gotcha. I want to make sure you know about it, because you can do that JSON formatting. Well, when it sees those curly braces for the cipher prefix, then YAML will kind of panic and say, this looks like JSON, but then you have more words after it. What's going on? So you just put in single quotes. So it's very simple. That's really the only case where you have to quote something in YAML. The only other place is if you have actual white space you want to protect, and like, oh, it has a leading space. I actually want it there, so you put the quotes in there. But there comes a place where you want to actually use some of those other YAML things. So before we look into that, YAML's easy to read. You can put comments in, which is huge if you've used JSON for configuration. And then this is kind of a nifty thing, is what if you have a long property and I want to turn it into multiple lines? So YAML lets us do that. One last point before I switch slides is that Spring actually does a Spring-specific thing to YAML. And it's not a big thing. YAML, by default, doesn't say anything if I've got two keys with the same value. So if I had name in there twice, YAML would be like, whatever, I'll just take one. Probably the last one, we'll see, right? So instead, Spring says, oh, there's two in here, blow up, like fail fast, which is good. I like that. But it is kind of a Spring-specific thing, and I'll show you why that's important later. But back to the multi-line thing. So this is the property endpoints.env.keys to sanitize. This is the property that tell it which ones to mask on the env endpoint. And what we noticed is it was massively long, and it just kept going on and on, because then we added in a bunch of our specific keys that were important to us, because as we were moving our legacy system over, there were things that had been encrypted before that weren't using the typical secret or password or whatever naming convention. And so with YAML, notice we can put the double quotes on there and put a backslash to escape the new line. And so that's actually treated as a single line. But for the purpose of source control, that becomes so useful to see, oh, who added what line when, or when was it, what was removed, and things like that. So that becomes very useful. One other kind of tip is this config props.enabled. There was a bug where it wasn't masking the same way, so we just disabled the config props because it behaves similar to the env endpoint. We don't want to leak stuff out. Maybe that's fixed in 1.4. I haven't tried it because I just upgraded. Okay. All right, so I mentioned something about how Spring does something specific with YAML where it doesn't allow multiple keys. We noticed that every now and then someone would miss a space, or this is the problem with YAML, is it is white space specific, right? And so we went and added a Grail task, and this is checked in if you want it. And so when someone went and added something to the config repo, we wanted to make sure it was valid YAML before they could push it. And so that we turn this into a pre-commit hook. It validates the YAML, and then it reports all the errors, and if it works, fine, not a big deal. And this fails maybe once a week, once every other week, and it makes me happy because bad config didn't get in the repo. So that also addressed that. Okay, so enough with those extensions. Now let's look at the actual fact that under config server, we've got source control. We've got traceability. We can look to see who changed what when, what the commit message was, why. You can use pull requests or any logic that you do around normal code to have conversations and request changes and kind of massage it before it gets merged in, right? Nothing surprising there, but very powerful. You can also use comparison tools, so I can compare, how has this changed in the past? Or if I've got two different environments, I want to kind of see what's different between the two, then that's useful. We push config server a little extra where not only do the individual applications pull in their configuration, our deploy service also goes and looks in config server for a given service's deploy properties. So what size of instance are they running, or their temp space, or stuff like that, right? So because of that, we might want to compare to see, oh, how big is the machine in dev as compared to prod? Oh, why is there a difference? When did that change? Things like that. So that tooling is there, as well as just having flat files are so excellent to automate against. So that's been good. This is how we set up our config server. So the top one is kind of the default, where the client comes in, an application's calling config server, and then config server, on every request, it's going to go and do a git pull, and it's going to say, hey, GitHub or wherever your repo is. Essentially, it's going to take a network hop, and so there's latency there as well as a potential for failure, right? And so when it went away, or in our case, we didn't want our config server to be able to go and look at all of our repositories because we didn't want to expose it. We wanted our cloud kind of isolated from where all of our source code is. And so instead, we use the second model. And so our application goes and calls our config server, and the config server has a bare cloned repo SSH onto the box. And so that does mean that there's an extra hop when we go and push out config, but since config doesn't change that often, as opposed to looking up config, we figured it was worthwhile. And so we just have a Jenkins job that whenever they commit to the repo, it runs our YAML validation, it passes, and then it goes and pushes it out to our config servers. And so that's how it's set up. And because we can call in, it just can't call out. So that's how we set it up. We tried a number of things, and we were most comfortable with that option. We laid out our config repository. You can do it a number of ways, which is fantastic. You can have one repository per team or whatever, but we opted for a single repository for all our teams because since we're doing pull requests against them anyways, and it's locked down in that sense, it felt pretty good. A restricted number of people can merge them in, and they merge them pretty frequently. So that's worked for us well because then we can do kind of diffs across environments to kind of compare and look how the different apps behave or compare to each other. We also have a subdirectory per environment. So and with config server, you can limit it to say, oh, if you're looking for an environment or a given profile, it'd be in this subdirectory or things like that. So it's nice in that regard. And now we've got two different kind of folders. We can just diff the whole folders, and that works well. The last point is, remember when we talked about the config server URL, where it could have a lot. It goes by the application name, and then it has the profile, and then it has the label. And it defaults to master. And we tried to reason through a number of ways of how we would leverage that. We said, well, maybe we'll have a branch per release, and then it would just be the same file, and we just compare the branches. And the more we thought of it was always complex, and there was always some reasoning. But now everything's on master, and because we've got subdirectories per environment, then we want to compare dev to prod. We just compare those two different files that are both on master. And so the question of what property is out there is very straightforward. It's just what's in master, that's the property that's out there. And that's been nice because it's been straightforward, and all the devs and anyone that looks in the repo understands it. So we haven't found a use case to use the label yet. I'm glad it exists because I suspected there is. I'm sure someone here has found a use case for it. Yes? If you have multiple versions out in production. So in that case, so let's say I've got version 1 out there, and version 2 is now getting deployed, and I want version 2 to have a new config. What we decided was, well, we just need to be safe in that we would either make the config change before or after, and they're going to be running parallel is how we approached it. Although that is a good use case, and we're like, well, we want to have this to have a different version when it rolls out. If that's the case, then what we said was go and put that in the source code itself, because if that's a property that needs to roll out with that, then it deserves to, it'll just naturally be different when the new deploy goes out. So that's been the only use case we ran into was when the actual nature of the applications changed, and having it local made a lot more sense. So that's how we addressed that. Okay, there was an excellent article. In fact, this Justin Smith guy, I don't know him personally, maybe he's here. He works for Pivotal, but that wasn't why I quoted the article. Is very, very good read, and he talks about these parts of security, and he talks about rotating, repaving, and repairing. I'm not going to focus on repave and repair. Those are mainly focused on make sure that your machines are refreshed and that they're fixed quickly. But the rotate aspect is interesting. And in his article, he talks about rotating your secrets every few minutes or hours, right? Which that's pretty fast. But if you can do it that quickly, then that'd be pretty safe. But the thing I want to call out about the article is the fact that whenever you have a secret, you need to address and say, how will I rotate this? How will I change it around? And so you noticed earlier when we encrypted a value that we encrypted that. And the key for that value, if you'll recall, was in that bootstrap YAML file of our config server. And so what if I wanted to change the key I used to encrypt all the other keys? That's something we have to think through. And so this is our first another extension we added to config server. It's got the concept of named keys. Notice how the cipher changes here, where we have a named key for what we've encrypted. By default, config server supports that, which is fantastic, but that's for asymmetric keys, meaning certificates, right? We wanted to leverage it with symmetric keys, meaning where we put those actual strings in the YAML files, because it was easier for us to kind of manage those and roll those out. In fact, we could put them in config server themselves if they were encrypted, right? So it's kind of like letting it manage that. So here you can see where we've got this encrypt keys, env environment A version 1 and B version 1, and we've got the keys in there, and so we might create a v2 and a v3, and that way we could serve up both temporarily while we update it and push it out, and then remove the other one, right? So we have a rotation strategy. So this was another extension we wanted to add in, and it's fit nice because it gave us that reassurance. Whenever config servers mentioned, and I think this is fantastic that they do this, Spring says, hey, you can enable config server, but there's no security. You need to add your own, right? And so as we were trying to figure out a way, how are we going to secure this? Because the config endpoints are serving up the config in the clear, and the decrypt endpoint at the very least I want to lock down, right? I don't want people to just pull something out of Git and be able to decrypt it. And so we need to lock it down. And so there's a number of ways. If you have a preferred one with Spring Security, feel free to ignore what I'm saying right now. But if you're curious on what's one mechanism you might use. So JWT, pronounced JOT, Json Web Tokens. These are very simple. They look like this. It's a couple JSON snippets and a signature, and they're base64 encoded. And so it looks like this, without the coloring, obviously. So the green part, that's the header. That's saying how was it encrypted or signed. The blue part, that's the claim set, or the payload, if you want to think of it that way. And the nice thing about that claim set is it's extensible, so you could add your own values. And then the red part is the signature that makes sure that validates, OK, this hasn't been tampered with. It's the value I expect it to be. So in this case, I've added on 2 custom claim sets, the app service and the app environment. So in this case, this token was issued to the my service, and it's for the dev environment. And so this is very useful because when we go and use it in config server, we can use that same JOT token, and when we go and parse it in, then we go and give it the role of role app service, my service, and role app environment dev. So once we have those, then we can just do a very simple Spring Security rule against that. I won't pull that up right now. We're using what's called a regex rule, and it's pretty straightforward. But this has been great because now when we've got that endpoint, /config, my app, profile, etc., then it can restrict that only my service in the dev environment can go and get the credentials for the dev environment. It can't go and pull down the prod ones. Yes. Where do we keep the JOT token? Oh, OK, good point. So when I deploy out a service, I'm going to give it a JOT token. And so we generate it on deploy and say, OK, this is what you have. And so when we deploy a service, we give it 2 things. We give it the credentials, so the JOT token, and it's just in the clear. So sorry, not in the clear. It's just the value, right? It doesn't need to look at it. Doesn't need to inspect it. It knows I'll just grab this value and put it on my request. In fact, I'll pull up the code to show how we look that up. And then the other value is the URL of the config server. So once it has those 2 values, a server starting up can go and say, oh, I want to go get these values. Yes? No. So we did this manually. So in the example code, you can see how we're doing that. Really, it's just a matter of parsing out the JOT token and then just adding a new authority to a new granted authority as we create it. In fact, let's pause and go look at what that looks like. So up here in this is really the only interesting code in the app module. Is if you go to the config client bootstrap configuration. So this is how you would create one, and really this is probably all you would duplicate. In this case, we are getting how we're authenticating. to the service using an authorization header, bearer, and then the value it went and pulled up. And so that's that JOT token. And so when we deploy it, a service either in the environment or somewhere, we went and set a config client secret so that when it starts up, it's just going to go and grab that value, put it in its in the REST template that it uses to go and get its config, and that's it. So this is really all the configuration that's needed for the clients. Yes? Right. Well, we generate on the fly because I might generate a token that expires after X days or however you want to do that. And because it's just a token with that claim set, it's just a JOT token. So in fact,
just landed on the instance and then the server goes to read any whatever file that's in and now it's back in memory.
Exactly. Yep. That's exactly how it works. And we generated a new one for each server. Actually, that's not quite the case if we're doing scale sets, but anyways, you get the idea. Okay, another extension we ran into is in CloudFoundry. CloudFoundry has this concept of services, a nice generic name that when you look at it, you're like, service, what's a service? Essentially what it is shared config. And we're not on CloudFoundry, but we had a similar need. In our current system, we could do a very similar thing where we call them devices, but it's the same concept, shared config. So in this case, imagine in my application-nightly YAML, so if you'll remember, if I have my service will go and look for its YAML properties for its environment, as well as any that are named application dash and then the profiles that match. So in this case, we've got a service called config server example, and we're passing in the nightly one environment. And so it's going to go and also get these, so it'll union these two with these properties winning. So just kind of as a review. So here we created the device definitions, and we grouped them. So here we got some MySQL ones. And we got some defaults, but the part that's interesting is these IDs. So on line 12 and 17, we've got a user DB and a secret user DB2. And then for cache, we've got a user cache. And so what we wanted to do is be a way to define all this shared config, but then filter it out. And so in the example repo, you'll see a filtering environment controller. And all its purpose is when it gets a bunch of device definitions, it'll go to see what are the actual devices that the service has and filter out the ones that don't apply. So this is how we address that. So it's been nice because it gave us the same functionality that shared config, but then in addition, it gives you that extra feature of it's in Git. We can track this. We can see who assigned this service at what time and when, and so on and so forth. So that's been very useful. The defaults section was kind of some gold plating at the time. We're like, oh, it'd be nice to have these, but it's been fantastic because all of our MySQLs might have the same. We actually cut out, there's actually like 20 other properties in there, like what the default tests query is to validate that it's healthy and timeouts and things like that. And so once you have that concept of defaults, it's been very handy. That being said, it's really only normalized here. We denormalize it when we send it out to the service because we want the service to be able to kind of have all the properties, right? It needs to know what are all the properties, whether they're defaults or not. Okay, so here's a summary of, all right, we're going well on time. Here's a summary of the extensions that we added in. And so if you have any questions about these or want to look at them. So I mentioned the token-based authentication using the JOT token to secure the endpoint. Exposing what the latest commission, I actually didn't show that one. We had a question of if I want to look at a given service to see what it think its last config was pushed and when, then it'd be nice if we could see that shot because then I could go to the repo and look to see what that is. So that's another extension we added in. The shared config support, that devices thing I just showed. The refusing to expose encrypted values is that oops property where when we decrypt it, we instead just put in a garbage one so that we don't leak out the secrets. And then that YAML validation Gradle task. So those are the ones that we're using. We still use them. Maybe we'll be able to eventually get those into the core or whatnot. Yes? The way I wrote it, but it's 3 lines, and really it just boils down to it just goes and finds all the files that end with .yaml, and it tries to load them in with the YAML parser. So it uses snake YAML. Anyone that wants to go and grab that and create an equivalent Maven one, or maybe we can get it into the main Spring Boot plugins would be awesome. But yeah, it's very simplistic. Some other extensions we added in that we just used temporarily is we're trying to do some performance, and so we made it, hey, let's make it so we can have a bunch of Git repositories repository being an internal representation, a JGet representation. So we tried that for a bit, didn't really help out. And then you notice when we encrypted things a bunch of times that it kept rotating. While we're dumping and converting our stuff over, for a short time we stuck it so that it wouldn't keep getting a different initialization vector every time you encrypted something, because when we're dumping it, we wanted to pull it out of the database, encrypt it, and then put it in Git, and we could see that it wasn't changing, and so I was like, okay, if it's encrypted the same value. But then again, that's a temporary thing, because that does lessen the security. So, but it was a good option for us as we were moving. Yes?
Another question about the configuration. Is it possible that one property, depending on some two other properties, we can pick up the value that's
Yes.
a country and a state? But if I'm coming from a certain country and a state, I want to pick up a value. And if I'm coming from some other country and some other state, I want to pick up some other.
Yep. So the question was, if I've got a property that's made up of other properties, can I get those on multiple passes? Is that right? And that is supported. And that's nice because the properties aren't evaluated at the config server level. They're evaluated in the individual application itself. And so it can do as many passes as it needs to resolve those. And that's very powerful because I might have some properties that are checked in the YAML file, the properties file in the service, and some properties that are coming from the config server, say what environment you are. And so maybe you built up your URL, it said environment dot yada, 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 right? So that environment can come from the config server, and the URL can go and parse that in, and whether it's using multiple, then it works fine. And you've noticed the placeholder syntax has kind of a default value where if you put a colon in it, that it can fall back. So all of that's allowed, and that's just because that's evaluated as late as possible on the application side. And correct. So we do not, those aren't stored in the config server at all. It's always, they're just passed through. And because you've got that property source hierarchy, then you can override and evaluate, and it just goes until it finds it. And if it can't find it, then it will fail fast and say, hey, I couldn't resolve this property. So.
A simple example is like for Canada, you have a Canadian dollar, and for US, you have the US dollar. Is that something I would specify in the YAML file or the server config, or it should be outside of it?
So,
Basically, from which, let's say I'm coming from a site which is Canadian site as opposed to probably a UK site or a US site, I want to show the currency code dependent on it.
so that's more resource bundles. That's so the question was if someone was coming from US versus Canada and they wanted to show the different internationalization, that's more a resource bundle kind of thing. Not really. You could read in your resource bundles from config server if you want to do something like that. And so externalizing that way is totally fine. But the actual like switching and things like that, that's more a Spring MVC kind of thing. Yes.
So using Spring Cloud Plus, either Kafka or Rabbit, we can do a push mechanism from config up to our services.
Yes.
Okay, so my question is, and I kind of face this, is that let's say I wrote a sensor microservice, and this sensor microservice is going to have multiple instances. And so I have multiple instances of, let's say, a line code sensor, right? And I want to pass in configs from my sensor A and B, but two different type of configs because of, because of their position in the cloud. Maybe, you know what I mean? Because I have this running at different availability zones. So my config, I guess my question is, can I pass in different configs based on instance type?
So the question was, can you pass in different configs based on instance type? And there's two different mechanisms you could use to control that. Here's in the demo, we've got our app. And in its resources, if you had two different instances, then they would both maybe give themselves a different application name. I'm config A and config B, or whatever. And since these are, again, Spring properties, and the Spring environment is so fantastic, those could be getting passed in via environment variables. They don't just have to be in the Bootstrap YAML. It could be coming from a command line argument. So you could set that. Imagine if they were the same code, but when you start them up, you wanted to have them behave slightly different. You could give them something different at runtime, and then they would go and resolve the config differently. So that's completely supported. Yeah, so all three of those knobs are there. So you've got the application name, the profile. Profile is actually probably what you'd end up using more, and then label. So, yes. Oh, sorry, what was that? How are we hitting the refresh endpoint right now? So remember how I was telling you our legacy system knows about all the services? So it just goes and iterates through and just curls each one, essentially. Yeah, exactly. And so, yep, yeah, so it happens to know about everything. And that in fact, is the thing I'm working on after this conference, is switching everyone to use the cloud bus. Because that's a much better model, because I don't want them to know about everything. I want them all to watch a queue or something. Yeah, so the concern is, well, is that endpoint secured or not, or something like that, and you don't want people to be able to call it. So, and you in fact can disable that endpoint, so that's totally supported. Yes.
So I saw you doing that filtering with my devices. Does that kind of make your Spring config server, in a sense, multi-tenanted, where you can have lots and lots of topic in one place with different applications, only draw down the configuration that's appropriate for that?
So the question is, does it make it multi-tenant so that services can just pull down the config that's appropriate to them? So by default, it is multi-tenant in that by having their different application names, they'll be pulling down their own config already. So here's an example. Here I've got config for a client and a server, and the client will only ever pull down his config, and then the one for the application YAML, so kind of the shared config at that level. And server is also only going to pull down his config. And so that's already multi-tenant, but it kind of takes it to the next step where, what if I have a bunch of shared stuff in here? And so yes, it also supports it kind of at one level further, where I don't have to go and duplicate this among several files. And so it makes this single file behave multi-tenant, if you will. And it's been very useful. Yes? Do I know any plans to support JSON files? I'm not aware of any, but that being said, since it's extensible, you can hook into how it's reading the file off the file system, and you could extend that. But yeah, I'm actually not on the Spring Cloud team, so I actually don't know, have any insight into what they're working on going forward. But like I pointed out, YAML can be JSON formatted, so if you wanted to just do a .yml and serve up JSON, that would work out of the box. Yes?
Are there any plans for allowing adding new properties to programs?
Sorry, I couldn't hear you.
Is there a plan to allow adding any new properties programmatically? Like right now it's only maybe static.
So that's built in. So in fact, it doesn't look too useful here, but notice this metadata. So I mentioned we added an extension where whenever we got a config refresh, that we would go and get the latest get SHA and embed that in. So here's an example where we programmatically added in one and generated on the fly. And we did that elsewhere. Spring Boot lets you go and set logging levels dynamically. And we had kind of a funky system that was doing logging in logback, but then also doing it another way. And so that was another place where we generated an extra property source of the log levels in this different format at the same time. So yeah, that's supported. In fact, the code, I believe, was very straightforward. Let's see. So here's the no, okay. It's probably baked in here. So I won't hunt around, but you're welcome to come up afterwards. Yes?
Yeah.
Oh.
In case of PCF requirement, when we have multiple instances of the server running, and then potentially we have multiple one endpoints as well. If we want to do a refresh, so how is it taken care of? We need to take the refresh URL from every instance, or will it be later?
So the question is, how do we refresh when we're out and we have multiple instances with multiple endpoints? And sorry, I should have restated this. The preferred way to do refresh is to use the Spring Cloud bus, like a RabbitMQ, where then when a refresh happens, it just posts to the queue that, hey, a refresh has happened, and let all the other services that are watching that queue say, oh, I'll go and pull it down. So that's the preferred way. For the purpose of the demo, and actually for the system because I had a legacy system we were kind of migrating over, we stuck with the refresh endpoint because it was very straightforward and it's very easy to demo here. And that's where I have experience with right now. But definitely the bus is better.
And how convenient is it? How convenient is it to set up? I mean, does it create its own maintenance headache or?
For having Spring Cloud Bus, how hard is it to set up? I'll find out next week. That's what I'm going to tackle. Yes. So the question was, how can we distinguish between different versions if I want to like try something new out? And something I didn't mention but is worth calling out is when a service goes and sends up. So the URL that it's for when it's requesting its config includes that profile, right? And what's nice about that profile section is it actually supports batching. And so if you have multiple profiles, it's not going to do multiple requests. It will comma delimit them. And then on the config server side, it knows, oh, let me go break those out, find all those different profiles and serve those up. So that's one mechanism you could use is when you deploy out your new service, you could tell it, there's a number of ways you can set the profiles. There's one called additional profiles that you can actually set in the YAML. And so it could kind of ask and add that in. So that's one mechanism, but really the sky's the limit. If you want to try using the labels and say, oh, look for this version and stuff like that, or even give it a different name, like all those are supported. Yes?
What we have is for the Spring side, the Java part, microservices, wall side, it works fine with the push mechanism via Cloud Plus. Correct me if I'm wrong, but now we have also Golang services as well, and we want to leverage this.
Okay. I like you.
Okay.
I'm learning Go right now, and that's my use case is writing a Go client for this. Because like I was saying, the Spring environment is just so useful because it reads it from the environment, reads it from the system properties, it reads it from command line, the flags, things like that. And Go doesn't have support for that. And I think that's the one thing. So I've actually got a couple people. So our Java services work great with config server. We got some internal people using Scala with Spring. That works great. But the Go services need a client. So I want to collaborate with someone on this because I'm too new to Go to really get it to going. But I know the config server backwards and forwards. So anyways, that's something I'm working on, or I want to work on right now. After I do get the COB bus, then we'll do the Go thing, right? Yes?
So your example seems to have non-sensitive and sensitive stuff sort of mixed together. Do you do your organization on that way, or do you segregate those things?
So right now we run that way, and that's nice because since they're encrypted in the Git repo, they're not exposed. And what we do for the encrypt endpoint, we actually created a nice little UI, and we said, hey, anyone from anywhere, we actually don't lock it down. We say, anyone, encrypt all you want. The decrypt is locked down, but the encrypt, anyone can encrypt it and then put it in a pull request and say, hey, I need to pull this in. So yeah, that's worked fine for us. So the question was, is it used programmatically? And the answer is no. Yeah, the dev says, oh, I got a new password, I'll go and do it. But you can. It is exposed as an endpoint that if you wanted to. In fact, just last week, one of the people at work was wanting to programmatically encrypt stuff. So actually, the answer is, yeah, they could do that. Yes?
So this is a talk later today on Vault. I was wondering if you had any experience with managing file secrets and config.
No, so I haven't used Vault yet. But yeah, Spencer has done a lot of good work with that, so worthwhile looking at. Yes? So you're asking if there's any security around letting refresh fire too often? So the question is, if the refresh endpoint was exposed in spam, you can lock it down because Spring security. But then the only work that's going on is any beans that have been wrapped in refresh scope, they'll just get thrown away. And so if you're doing busy work, yes, then there could be concerns there. But really, you wouldn't want that in refresh scope anyway. So I don't think there's security concerns. There might be some kind of performance impact. But frankly, you wouldn't want it happening. so better to lock it down. Because really, you wouldn't expect people to be hitting that endpoint. You'd expect whatever your system is. And frankly, the Spring Cloud Bus is a better mechanism anyways. Yes? My experience, so the question is, are there any threading concerns? I don't believe so. I think it's just I could be wrong, but the Spring application, when it publishes the event, that it's happens on a single thread, is my experience. Yes? Mm-hmm. Yes. So the question was, why do just one repository for all your teams as opposed to many repositories, one for each team, things like that? Frankly, we made the decision because it didn't matter. We could split it out later, and we knew the config server could support us in that because we validated that. In our case, we just wanted to make it easy for adoption because we're pretty big. We've got 200 plus developers, but we're not too giant, and so we're able to communicate so far. So the question was, well, if you're sharing the repo, how do you make sure that teams don't step on each other's toes? And it boils down to communication. In our case, teams typically would only put stuff in their application YAML anyways. They're not, in the specific one for their service, not in the shared one. And so we haven't run into that. So just to, they would put it in these specific ones, or more likely for their environments, they typically don't touch the environment-wide ones. Is really what it's boiled down to. Someone over here? Okay.
You guys are using the same repo for prod and prod?
Not really. Prod and dev, that's really how we've split it out. We've got a test one that we kind of hit like crazy and do all sorts of crazy stuff against. Then we've got the dev one, which is really a type of prod because if it goes down, then dev's going to be in trouble. And then we've got our prod one. So we do separate those two, but. No, they're completely different config servers pointing to completely different repos. So the question is, how do we compare dev and prod? Since they're different repos, we can just check them out, and once we have them both, we can just do it across file systems or directories or something. That works pretty fine. Sorry, what was that? We just make, so the question was, do we do blue-green deployments? And the solution is we make it so that they both can run off the same config, and then we decide that if there's something that's changing as part of that deploy, then check it into the code that's coming up. If it's something that they can both handle, change it before the deploy. If it's something that they can't both handle, change it after the deploy, and then the first one comes up with the initial values. So that's kind of how we delineated those three things, and that's met all our needs. Yes. So the question is on app start, does it make a call? And the way it is programmed is yes, it does make a call on startup. And you can, one of the first things I mentioned is you can actually make it so that it will fail. So if it makes a call and can't complete that call at 404 or a timeout or whatever, then should that service stop or should it come up in without having made that call? And so that's a setting that you can do. And so, yes, on start, services would make a call. And so it could become a single point of failure in that you just need to scale it out, right? You need to have it be able to respond. That being said, we haven't run into that problem yet. In fact, we've kept it scaled very small so far and haven't run into any problems. And that's even with our deploy system calling on behalf of other services. So we're calling, kind of making it do extra work because when we do a deploy, we're doing many, many, many requests to collect them all and to pull them in. And so if anything, we kind of DDoS we put extra load on it, and it's worked fine. Especially considering, and scaling it up isn't really a concern because it's really a read-only system. Config server, the endpoint, the encrypt endpoint, for example, it doesn't store anything, it just returns the value back. And so scaling up is very, very straightforward. I'm not very concerned in that regard. Anyone else? Yes?
Can you put up your last slide again?
Sure. So the question was if I could put up my last slide. And my last slide is really the credits, but we'll do this one instead. Okay. Back there? Is there someone? Okay. Sir? So the question was if we have any kind of user interface for managing properties. We talked about doing something like that, but the YAML is actually as good as it gets, really, when we looked at it, because it was the key values. We wanted to be able to edit them and stuff like that. So we've done some stuff to kind of make the env endpoint a little prettier for our example, but that's just because we had our legacy system, and that system just keeps on serving it up. And so that's not something we're going to open source or anything, but there actually is a project out there called Spring Boot Admin, and I think it puts a pretty face in front of the env. You could look that up. It's some Angular app. Actually, I've looked at it. I've never actually fired it up, but I think that exists. Yes.
Is there a scheduled refresh compilation?
So the question was if we could schedule refreshes. Currently, it's only whenever a config changes, and so. But since those refresh endpoints exist, or even if you just want to go to the refresh scope bean within your application and programmatically tell it to refresh, all that would be supported. So that's not a problem. Yes?
Is there an option to store properties in database instead of
So the question is, can config server go against other data sources like a database? And the answer is yes. I haven't worked with that one, though. At this point, if there's just questions, everyone else is welcome to leave, or if you guys want to keep asking questions, there's 4 more minutes. But either way is fine.